Almost all the work parts must be cleaned one or more times during their manufacturing sequence in order to prepare the surface for the subsequent processing, such as the coating applications or the adhesive bonding, also to improve the hygiene conditions for the workers and the customers, and to remove the contaminants that might chemically react with the surfaces. Finally, to enhance the appearance and the performance of the product. The processes used to clean the work surfaces can be classified as the chemical cleaning methods and the mechanical cleaning. The chemical cleaning processes include the alkaline cleaning, emulsion cleaning, solvent cleaning, acid cleaning, and ultrasonic cleaning. The mechanical cleaning processes are a physical removal of soils, scales, or films from the work surfaces by a pressure or similar mechanical action. Often serves other functions also, like for example deburring, improving of the surface finishing, and the surface hardening. The processes including the blast finishing, the shoot being, and the mass finishing operations. There are many factors involved in the selecting of the cleaning methods, including the contaminants to be removed, the degree of the cleaning required, the substrate materials to be cleaned, the purpose of the cleaning, the environmental and the safety factor, the size and the geometry of the part, and the production cost requirements. Coating of engineering materials. The metal products are almost always coated by painting, plating, or other processes. The only exception we have is for the stainless steel and the brass. Non-metallic materials are sometimes coated, like for example, the plastic parts to give a metallic appearance, the interreflection coating on the glass lenses, and the coating and the deposition processes used in the fabrication of the semiconductor chips and the printed circuit boards. Two processes that impregnate the surfaces of the substances with foreign atoms. Diffusion, which is the alteration of the surface layers of the materials by diffusing atoms of different materials. Usually, they are going to be an element into the surface. Usually, it's going to be done at a high temperature. And we have the ion implementations, which is the embedding of the atoms of one or more foreign elements into the substance surfaces using a high energy beams of ionized particles. Why coating the metals parts and the products? This is going to be very useful for the corrosion protection, enhance the product's appearance, wear resistance and or the friction reductions, increase the electrical conductivity or resistance, prepare the metallic surface for the subsequent processing, and finally the rebuild of the surface worn or eroded during the service. The most common processes are going to be the electroplating, the electroforming, the electrolysis, and the hot dipping. The main purpose of the plating is adding the coating of the thin metallic layers onto the surface of the substrate material. The conversion coatings is a family of the coating processes in which the thin film of the oxides, phosphates, or the chromate is going to be formed on the metallic surfaces by a chemical or electrochemical reaction. The immersion and the spraying are two common methods of the exposure of the metal surfaces to the reacting chemicals. The common metal treated are going to be the steel, the zinc, and the aluminium. The conversion coating processes, including the phosphate coating, the chromate coating, the anodizing, which is the most common use in the aluminium and its alloys. The physical vapor deposition is a family of the processes in which the material is going to be converted to its vapor phase in a vacuum chamber and condensed into the part surface in a very thin layer. The coating materials can be metals, the alloys, the ceramic, and other inorganic compounds. Even some polymers are possible to be used. The substrate is going to be the metals, the glass, and the plastics. It's very versatile coating technology and requires very high intensive vacuum. The chemical vapor depositions involve the interaction between the mixtures of gases and the surfaces of the heated part, causing a chemical decomposition of some of the gas constituents and the formation of the solid film on the substrates. The reaction will occur in any closed reaction chamber The reaction products nucleates and draws of the substrate surfaces to form the coating, and most of the chemical vapor deposition reactions require heat. The variety of the coatings and the substrate materials are available. The polymers and the resins, usually formulated to be applied as a liquid, dry or harden as a thin film on the substrate materials. The advantages of the organic coatings are the wide variety of the colors and the texture available, the capacity to be protect the substrate surfaces, come with the low cost, and ease with which they can be applied.